Secure IIoT integration with SEEBURGER, resilient data exchange for industrial systems. The industrial Internet of Things is transforming industries worldwide, enabling unprecedented transparency, efficiency, and innovation. But with every new connection come new risks. Secure connections and interactions in IIoT are not optional. They're essential to ensuring operations, protecting data, and securing sustainable growth in a hyper-connected world. While IIoT has been opening exciting new opportunities, such as predictive maintenance, smart supply chains, and even fully automated lights-out factories, it also introduces serious risks. Every connected device, every data stream, and every system integration adds another potential entry point for cyber threats. Without robust security, the very networks designed to accelerate business growth could become major vulnerabilities. In this article, we explore the specific challenges of IIoT security, the risks at different architectural layers, and strategies for protecting your IIoT connected environment. We'll also look at how a platform like SEEBURGER BIS can help companies interact in industrial ecosystems securely and effectively. Why IIoT security matters more than ever. IIoT connects machines, devices, and systems across production, logistics, energy, and beyond. This constant flow of real-time data powers functions like real-time asset tracking, energy optimization, and remote production control. However, the same features that make IIoT valuable, massive connectivity, remote access, and real-time control, also make it a huge target for cyber threats. As industrial devices increasingly join the network, the attack surface grows exponentially. According to Microsoft's Digital Defense Report 2023, 78% of industrial network devices monitored were found to have known vulnerabilities. Without strong protection, businesses face threats such as production downtime, intellectual property theft, regulatory fines, and reputational damage. The bottom line is that if your IIoT environment isn't secure, neither are your operations. Where IIoT is vulnerable. Understanding attack surfaces. Securing IIoT starts with understanding its architecture and where it's most exposed. One of the most basic ways to view IIoT security is through a three-layer model: devices, networks, and applications. Each of these layers has unique vulnerabilities that require targeted strategies. However, it's important to recognize that real-world IoT environments are often far more complex than this simple view suggests. In addition to devices, networks, and applications, modern architectures typically include field-level devices such as sensors and actuators, fog nodes that enable local decision-making, edge computing layers to process data near the source, data aggregation hubs, cloud orchestration platforms, and even AI-driven analytics layers for real-time insights. In the industrial Internet of Things, IIoT, potential connection points for exchanging data, what we might call data chains, exist at every level of the system. But with each new layer added, the system becomes more complex, increasing the attack surface and introducing new risks to data integrity, orchestration security, and system resilience. That's why it's essential to secure the foundational layers, devices, networks, and applications, as well as the data layer that builds on top of them. This is key to ensuring a secure and resilient IIoT environment. Vulnerabilities in the IIoT device layer. At the device layer, sensors, actuators, meters, robots, and connected equipment are often deployed in uncontrolled environments. This leaves them vulnerable to physical tampering, theft, firmware manipulation, or malware injection. Devices frequently suffer from risks such as unencrypted data storage, use of default credentials like admin, lack of tamper detection mechanisms, and insecure firmware update processes. Vulnerabilities in the IIoT network layer. Moving up to the network layer, the transmission of data over wired and wireless channels using protocols like MQTT or OPC UA introduces new attack vectors. Threats at this layer include eavesdropping attacks, man-in-the-middle attacks, unauthorized access via insecure Wi-Fi configurations, and malware propagation across interconnected devices. Vulnerabilities in the IIoT application layer. At the application layer, the vulnerabilities shift towards user interactions and cloud integrations. APIs, analytics, dashboards, and remote management tools often serve as entry points for cyber attackers. Common risks here involve insecure APIs exposing sensitive data, poor authentication practices, weak encryption for data storage and transmission, and a general lack of monitoring that fails to detect suspicious activities in time. The first step in building a resilient security strategy is to understand the vulnerabilities that exist across all layers, both in the foundational systems and in the newer, interconnected data layer that sits on top of them. Real-world IoT security risks. Theory aside, real-world examples demonstrate the urgency of securing IIoT integration within these data layers. Malware intrusion remains one of the biggest threats, with attackers compromising devices to gain deeper access to operational, OT, and IT systems. Devices that are misconfigured in promiscuous mode can inadvertently expose sensitive network data, creating unintended vulnerabilities. In addition, poorly coded device or service software can open the door to buffer overflow attacks, allowing cybercriminals to execute malicious code remotely. Insecure APIs and inadequate API management further expand the threat landscape, as attackers can steal, alter, or even destroy critical data. Without robust integrity checks, sensor data can also be tampered with, leading to operational errors or even physical damage to infrastructure. These examples highlight why IIoT security requires much more than traditional IT defenses. It demands a specialized, layered approach tailored to industrial environments. How to secure each layer of your IIoT environment. Building resilience into your IIoT environment requires securing each architectural layer with targeted actions. At the device layer, organizations should prioritize hardware-level encryption and immediately change default credentials upon deployment. They should also activate tamper detection mechanisms and regularly deploy signed firmware updates to protect against malicious code injection. On the network layer, it is essential to use secure communication protocols such as MQTT with TLS and encrypted payload. Segmenting networks with VLANs and industrial firewalls can keep breaches contained before they have the chance to escalate. It's also important to install specialized intrusion detection systems, IDS, tuned for industrial traffic to continuously monitor network behavior and quickly flag anomalies. For the data and application layers, implementing strong multi-factor authentication, MFA, is crucial. APIs should undergo regular security testing, with protections like OAuth, input validation, and API gateways in place to reduce exposure. Encryption of all data, both in transit and at rest, needs to be standard practice, reinforced by continuous vulnerability scanning and penetration testing routines. The growing use of cloud technology, especially at the data and application levels, has also increased connectivity to a more vulnerable cyber environment. Beyond technical controls, organizations need to ensure strong data governance processes. Applying the CIA triad, confidentiality, integrity, and availability, creates a foundation for trustworthy IIoT systems. This means using asymmetric encryption for device communications, cryptographic hash functions like SHA-256 for data integrity, and designing systems with redundancy to protect against downtime. Adherence to GDPR and other data sovereignty regulations is essential, especially when processing personal or sensitive industrial information. How SEEBURGER BS helps secure your IIoT ecosystem. Managing security for IIoT integration across all layers is nearly impossible without an integrated solution. That's where SEEBURGER comes in. The SEEBURGER BIS platform offers comprehensive security capabilities for IIoT integration scenarios. It secures data integration by encrypting device-to-cloud communications through protocols like MQTT and OPC UA. Its centralized API management protects internal and external APIs with OAuth 2.0, API keys, and rate limiting to thwart unauthorized access. The BIS platform also ensures GDPR readiness through robust data masking, encryption, and controlled access governance. Whether companies process data on the edge or across multi-cloud environments, BIS offers secure integration for IIoT environments tailored to industrial needs. Automatic patch management keeps IIoT environments and ecosystems protected against evolving threats, while real-time monitoring enhances visibility across IT and OT landscapes. By empowering businesses to integrate IT and OT securely, SEEBURGER helps transform IIoT security from a liability into a competitive advantage. Final thoughts. Security is the foundation of IIoT success. The industrial Internet of Things opens up enormous opportunities, but only for companies that can interact with it securely while ensuring data sovereignty. Secure IIoT integration isn't just about protecting devices and infrastructures. It's about safeguarding operations, brand reputation, and future growth. Building resilient IIoT integration means addressing vulnerabilities and ensuring security at every layer, including the various IT nodes, and reinforced with strong data governance practices. It demands an integrated, future-ready approach that evolves alongside technology. With the SEEBURGER BIS platform, companies can take control of IIoT integration and lay a secure foundation for their business processes in a connected world.